Okay, section 6.3, volumes of cylindrical shells. Okay, when we use the slice method, a typical slice method, the typical slice will be perpendicular to the y-axis. The integration will be along with the y-axis. The increment will be dy, and the integral will be a function of y. So that entails solving the equation y is equal to f of x for x to get an equation of the form y, x is equal to g of y. The task may be not easy. So, in this section, we are going to investigate another approach. One that doesn't require solving the equation y is equal to f of x for x. Okay. That method is called the method of cylindrical shells. As you see in figure 1, a cylindrical shell with inner radius r1 and outer radius r2 and height h. Its volume v is calculated by subtracting the volume V1 of the inner cylinder from the volume V2 of the outer cylinder. Okay. So, this volume of cylindrical shell can be obtained by subtracting V1 from V2. So, the volume V2 can be obtained by pi R2 square H, and volume V1 can be obtained by pi R1 square H. So that can be simplified like this, and which can be obtained as 2 pi times R2 plus R1 over 2 times H times R2 minus R1. Here, let the thickness of the shell be delta R, which is R2 minus R1, and the average radius of the shell be R is equal to 1/2 of R2 plus R1, which is this. Then, the formula for the volume of the cylindrical shell can be obtained by V times circumference times height times the thickness of shell, which can be written as V times 2 pi R, H, and delta R, like this. So, when we try to find the volume of a cylindrical shell that can be obtained by 2 pi r, which is the circumference, times the height h times the thickness of the shell, which is delta r. And then we use it to adopt the Riemann sum technique to find the volume. So let's see. Let S be the solid obtained by rotating about the y-axis, the region bounded by y is equal to f of x, where f of x is non-negative and y is equal to 0, and x is equal to a and x is equal to b, where the both are positive and the b is bigger than a, as we see in figure 2 here. We want to find the volume of this kind of object. Okay, here. So, in order to find the volume of this object, we divide the interval A from A to B into n sub-intervals, and let's find the midpoint in each interval, and then use the formula to get the volume of that each slice, which is Vi, can be obtained by 2 pi r times f of r, height times delta x, like this. Then add all of those Vi's to get the approximation of the volume, and then send n goes to infinity to have this. So this formula, like you see in the Riemann sum, and this limit sigma will go to the integral from a to b, and 2 pi x times f of x times dx. So this formula will give us the volume of this type of cylindrical shells. Okay, so the volume of the solid in figure 3 obtained by rotating about the y-axis, and the region under the curve y is called f of x from a to b is this. Integral from a to b 2 pi x f of x dx, where a is like this. So this is exactly same as like what we saw. Circumference times height times thickness. And okay. So also, yeah, this kind of the tunnel can be stretched like this. 2 pi x times delta x times h of x. 무슨 말인지 알겠? Okay, this figure 4 shows what we have done. So example 1, the region R between line y is equal to 0 and curve y is equal to 3x minus x square rotated about y-axis to form a solid of revolution S, and find the volume of revolution. This is what we are looking for. We have we want to find the region between line y is equal to 0 and curve y is equal to 3x minus x square, 3x minus x square, rotated the y-axis to form a solid of revolution S. Okay, so what? So as we see in the figure 5, we use a cylindrical shell method because y is a dependent variable, and here the x-axis at x is equal to 0 and x is equal to 3. So it's x is equal to 0 and x is equal to 3. The curve crosses x is equal to 0 and x is equal to. So as we see in this figure, this whole volume can be obtained by rotating this slice like through this, and add all such things from 0 to 3, not 2. Here, this should be 3. Okay, so this volume, so we now use the cylindrical shell method. So this V can be obtained by integral of 2 pi x times f of x, which is 3x minus x squared dx from 0 to 3. Because we're going to rotate this function from 0 to 3, not 2. Okay, so the volume, it can be obtained as 27 over 4 times pi, as we see in here. As you see in here. Copy and paste, and then, yeah. As you see, this works much better in Chrome. Okay. Here, we are looking for the we are rotate this shape with respect to y-axis like this. So we are looking for this volume. We may just rotate it. Positive and style, color, zoom, spin, on. We are looking for the volume of this object. And also that's what we found. Here, we are and the answer was given as we see in here, as a 27 over 4 pi, just to integrate this function from 0 to 3. Okay, next example shows asks us to find the region R between the curve y equal x and y is equal square root x is rotated about the y-axis, and find the volume of the solid of the revolution. the revolution, the solid of revolution of this region, which is this. We have a square root of x and y is equal to minus x. We want to rotate this with respect to y, and we are looking for this. I want to show that first to you. Okay, we want to. We want to rotate this one, square root x and y equal x, and we are looking for the volume of this. Spin. How we can find it? How? Okay? Like what we did before, what we have to do is just use the cylindrical shell method. We do integrate from 0 to 1, where these two curves meet. 1 and 0. For integrate from 1 to 0, 2 pi x times f of x times dx. So it's a very simple, easy computation to get 2 over 15 pi, which is formulated in here to be simulated. Same thing here. Determine the volume of a solid obtained by rotating about the x-axis, the region under the curve y is equal to 2 square root x from x is equal 0 to x is equal 1 using cylindrical shell, like this. Cylindrical shell. We want to rotate this one with respect to x-axis instead of y-axis. So the only difference thing is integral from 0 to 2 with this y-axis to 2 pi y f of y dy. That's the only difference. Okay, so just the volume is integral from 0 to 2 pi y times y f of y, which is this, and we have to subtract the 1 because we have to subtract this part, and so from y2 minus y1, and the height is this, and then we do integrate it to get 2 pi. For example 4, compute the volume of a solid obtained by rotating the region bounded by y is equal to 4x minus 2x squared and y is equal to 0 about the line x is equal to 2. Here, in this case, we want to rotate this curve bounded by this with respect to x is equal to 2 here. So this will rotate So this slice of piece will rotate it like this. So we have to find this volume first for this slice, and then we do integrate that formula with respect to x from 0 to 2. 0 to 2 to integrate it. So 2 pi y f of 2 pi y 2 pi x f of x dx. In here, x should be shifted, so it should be replaced by 2 minus x, and also the f of x should be shifted, so it can be obtained as 4x minus 2x squared. So that which gives us this 2 pi x prime and f of x prime dx, which is 2x cubed minus 8x squared plus 8x to integrate. And the integration will give us 16 over 3 pi. And the next, and this is the last example of section 6.3. Find the volume generated by rotating the region bounded by the given curves about the y-axis using the method of cylindrical shell. Same thing. And y is equal to minus 6 plus 2 sine x, y is equal to y is equal to 0, x is equal to 0, x is equal to pi over 3. And we may draw the graph first. We may draw the graph, which gives us this. We want to rotate it like this. We are looking for the volume of this. We are looking for the volume of this, which is this, which is obtained with this command. As you see, we just draw the graphs here, and then what we did was integrate 2 pi x f of x dx from 1 to 3. 1 to pi over 3, because from this graph, the height is from 0 to, from the point that we meet is the pi over 3, which is this. We do integrate from here to here to rotate this one. So this is very simple. This is, this example is one of the easiest example. What we only had to do was integrate from 0 to this point, which is pi over 3, and 2 pi x f of x, which is this, from the question. The minus x plus 2 sine x. So without many manipulation, we just put those functions in it to draw the graph to find out the intersection point and integrate it and rotate it and show it and to get what you like to have. Integrate like this. Integrate. Okay, so what we have done was, with this given information, we did integrate 2 pi x times f of x, which was minus x plus 2 sine x dx from 0 to pi over 3, which was the intersection point, to get the answer like this. And that's the typical example of finding volume of cylindrical shell by using the cylindrical shell method. There are examples, exercise problems on section 6.3 from here, so you may go through it to check whether your answer is right or not with your own problems. This example shows, this is the Olympiad game that North Korea and South Korea went together to have a photo together. And this is last year's International Math Olympiad contest, where the Korean team made the rank number 1 among the whole country. The second ranked team was China, and third ranked team was United States. And first ranked team was Russia, and others are Canada and Singapore, etc. Anyway, I think that will lapse up to section 6.3, and we will continue to finish up the section 6.4 work and 6.5 the average of the function. Do you have any questions?